We provide immutable infrastructure. They just blabber on like this. But if you go and ask them what immutable means, they don't know.
Hello, I'm Tony Koh, the host of Talk IT Global. Today's interview is prepared for those who want to quickly and easily understand current popular concepts of Kubernetes and containers. We'll be discussing what the term orchestration means, why properties like immutable and layer come up when talking about containers, what the components of Kubernetes are, and how recovery and security are managed. We've selected only the most commonly asked questions to discuss with Mantek's Executive Director, Lee Jin-hyun.
Automation is primarily focused on detecting something, deploying it, and specializing in deployment and detection. For example, let's say I deployed Tomcat and a database. Deployment can be automated by someone. We can use automation tools to perform deployments. And if deployed infrastructure, database, and middleware fail, and the monitoring automation tool has also monitored it, a problem has occurred. Who takes action then?
Shouldn't operations handle that?
Most of the time, a person comes and takes action. It depends on people, right? And when a person comes to take action, if a good engineer arrives, the issue will be handled well. But if a junior is there, they must wait until a senior arrives, right? So the quality is dictated by the people involved. That means it's not truly complete automation, right? That's orchestration for you. From this perspective on automation, saying that it will automate even the actions to be taken is an added feature. Now, that's what orchestration is. So if there's a failure, I'll automatically revive it for you. Look, it's under heavy load. Wouldn't we need to scale out then? I'll handle that automatically for you. That's the additional concept. That's the additional concept you should consider. When we look at software, the file that turns the software into an image is an ISO, right? So for example, let's say you install Windows OS. Now, if you are going to install Windows OS, you have a CD that contains an ISO file. Does the operating system function with just that ISO file?
It doesn't work by itself. It needs to be executed.
You have to install the packages and launch the Windows program before you can actually use the Windows OS. The same goes for Office. Similarly, this is how containers work. We store containers in a file form, which we call an image. And only by running this image and loading it into memory can we actually use that image.
So an image itself doesn't have the concept of running.
We are talking about the operation of that image. This operation is what we refer to as runtime. What does immutable mean?
It means unchangeable, right?
Immortal, unchangeable, once created, it never changes. So simply put, it's like read-only. Read-only in terms of storage. You know what worm storage is? Once you write to it, you cannot alter or tamper with it afterward. Think of it as an infrastructure where tampering is impossible. How about VMs? And what about physical servers? You can manipulate files on the OS as you like, right? That's not possible with containers. When executed, a rewritable layer is created, allowing files to be saved and changed. However, when shut down and restarted, it reverts to its original state.
For those familiar with traditional IT infrastructure, the concept of containers might be somewhat foreign.
It's indeed a foreign concept. That's why people who expect containers to function like VMs find them very inconvenient. Let me explain using an example from our company's experience. Back in 2014, we adopted containers. The package we were using internally had its own database. So all the data was stored within the container. Then suddenly the data was gone. We thought, what happened? Is there something wrong with the disk, the storage? We just didn't understand the nature of containers at that time. Later, we realized that containers shouldn't store data permanently. Containers can't keep internal data. If restarted, the data resets, reverting to the original immutable image. So how do we handle data then? That's where persistent volumes come in, creating a durable volume to attach. This data is stored externally, ensuring the immutable characteristic remains perfectly intact, allowing the environment to be resettable by anyone, anytime. In comparison, so if you manipulate a VM, so how do you revert changes? You'd need to bring in a backup and restore it, but even the backups might be tampered with, especially with ransomware attacks, which are common. Some vendors claim hypervisors aren't susceptible to ransomware, but we've seen many cases where the hypervisor itself is compromised, preventing VMs from launching. Thus, VMs and similar technologies are highly susceptible to manipulation. However, containers allow you to bring back the original image and restore it, even if someone tampers with it. This property is why we refer to it as immutable. If I need to add something more, I would need to consider the layered structure. Each layer of an image created is read-only and inviolable by anyone.
You just add one more layer.
You create and stack another layer, and then you can create the image.
So there are many different images then.
For instance, now suppose there are existing layers labeled A, B, and C. You add another layer D on top of A, B, and C. Then you create another container image with layers A, B, C, and D. If the file sizes are 1 megabyte for the initial layers and 1.2 megabyte including layer D, you might think that would total 2.2 megabyte on the disk. However, it doesn't add up like that because only the additional incremental layer increases the storage used.
This feature can indeed make operations very agile if used properly, especially in development.
That's one of the advantages of containers. If something goes wrong, you can revert to the original unchanged image. This makes rolling back changes very easy later on. In a typical Kubernetes setup, you have what are known as master nodes and worker nodes. When you create a Kubernetes cluster, it comprises several nodes. The most crucial among them is the master node. Think of the master node as the management element that oversees everything. Just like I mentioned about virtualization tools that manage the entire system, the master node serves a similar purpose for managing the container workloads. Then there are worker nodes, which actually run the user's applications inside what are called pods, a collection of containers. These pods package up the containers to run the applications. The operation of these pods on the worker nodes is what we refer to as the worker node being active.
So the worker node can operate multiple pods simultaneously.
Multiple pods can be present in a worker node. And these pods may all provide the same service. For example, if there is one pod running, you might scale it out to 5 pods. Then these 5 form a collective that provides the same service, right? These 5 identical pods need to be managed by a load balancer. And from an external perspective, it should appear as if they are a single unit. This concept is referred to as a service.
What about namespace?
A namespace is a way to segment cluster resources among multiple users. Worker nodes can either be physical or virtual servers. Suppose there are 3 worker nodes available. These worker nodes need to be allocated to users based on their requirements. For instance, one user might only need 2 worker nodes, while another might need all 3. Additionally, each worker node contains cores and memory. And this memory and computing power need to be divided and allocated to users according to a certain scale.
Or divided among different departments.
A namespace is a logical collection used for allocation. The definition of a namespace specifies which nodes you can use. It also sets limits on the resources such as CPU and memory that are available on those nodes. Additionally, if you look in the container repository, there are numerous container images available. From those images, you are only authorized to use certain ones, as permissions need to be set accordingly. So when assigning a namespace, these permission settings are used to allocate resources.
Administrators often manage users through namespaces.
Exactly, allocation is done on a namespace basis. This is also commonly referred to as tenancy management. Kubernetes itself is designed based on the principles of chaos engineering. Chaos engineering assumes that I can always fail and I can always die. Normally, when we create servers, we often say, our server will never die. It's impossible for it to fail. But in the cloud world, the concept is different. Unlike physical servers, the cloud inherently assumes I can die, I am a transient entity.
Like a cloud.
I will disappear and dissolve like rain. That's how things operate under this premise. So what happens then? I am inherently weak. I can disappear anytime, but disappearing is not an option. Instead, it operates on the principle that even if I disappear, another container will continue to provide the service that I was offering. That's the foundational principle they start with. Therefore, they inherently provide a system that can operate continuously without interruptions. Looking at the Kubernetes architecture, the master node is always configured with triple or quintuple redundancy. Worker nodes are also duplicated by default. Additionally, Kubernetes provides a self-healing feature when a pod fails. It automatically revives the pod, and typically not just one pod is operated. Several are deployed to create services that are load balanced. This approach ensures that the operations are always highly available.
Lastly, your likes and subscriptions greatly empower us to continue creating content. Thank you for your support.